Alright, a z-score is basically the number of standard deviations above or below the mean. If you have a positive z-score, that means you're above. If you have a negative z-score, you are below. So they give us this formula, which basically means the data minus the mean divided by the standard deviation. So in problem number 1, given a mean of 125.07 and a standard deviation of 136.4, what are the z-scores for 0 and what is the z-score for 480? So for 0, you would take 0 minus the mean and divide it by the standard deviation. Make sure that you put these in parentheses. And you get the answer of negative 0.919. If we want to do the z-score for 480, and that makes sense that this is negative because 0 was below the mean. So 480 minus 125.07 and parentheses, because you need it in parentheses, and this is 2.60, which is 2.6 standard deviations above the mean. We use z-scores to compare different measures sometime. So let's do another one. For example, number 2, we're given the mean is 40.89. What is the z-score for 21? What is the z-score for 26 or for 56? So 21 minus the mean, which is 40.89, divided by the standard deviation, which is 6.8. So this would be an answer of negative 2.925. And then we want the z-score for someone who had guessed an age of 56. So the answer would be .22. Question number 3 now gets into the comparing two different tests. So my test had a mean of 70 and a standard deviation of 6. Ms. Fader's test had a mean of 75 and a standard deviation of 5. If you scored 80 on both tests, which one did you actually do better on? So we'll call this FR for Friedlieb. So you scored an 80 on both tests. My mean was 70 and my standard deviation was 6. So when I plug that into my calculator, I get 1.67. For Fader, the mean was 75, and the standard deviation was 5, so that's only a standard deviation of 1, which means you actually did better on my test, even though you actually scored 80 on both tests. When comparing both tests to the entire group, my test was better for you. So example number 4 talks about blood pressure. And so the average blood pressure for a man is 140 with a standard deviation of 6. And the average blood pressure for a woman is 130 with a standard deviation of 8. My blood pressure is 150. Mrs. Freeland's is 140. Who should be more concerned? So 150 minus for me. So subtract the 140 and divide by a standard deviation of 6. So that turns out to be 1.67. And 140 minus 130 divided by 8. 10 divided by 8 is 1.25. So who should be more concerned? Well, mine, it seems to be too high for my age, and high cholesterol or high blood pressure is bad, so I should be more concerned. Last question, what happens if we both changed our blood pressure to be 100? So 100 minus 140 divided by 6. Turns out to be negative 6.67. And 100 minus 130 divided by 8. Turns out to be negative 3.75. And this would be considered unusually low. This is also fairly low. So I think we should both be concerned and make sure that everything's okay. And that's it for Z-scores.